Welcome back, MEFB 213-2013 Manufacturing Processes class. Today I'm going to continue on cold working process. So if you remember in the last lecture, we spoke about hot working. So what's the key word for hot working? Heat up the metal to a temperature above recrystallization temperature, and when the material is in semi-solid state, you're going to shape it. Therefore, the tools that you use or the equipment that you use in the shaping process has to be heat resistant. Now, as we move on to cold working, if we look at cold working, same exact concept. Okay, so cold working, what's the definition of cold working? Cold working is a plastic deformation, rolling, extrusion and drawing of metals below their recrystallization temperature. So basically, when you say below the recrystallization temperature, it actually happens in room temperature. Okay, so take a pencil or a pen for example, and try to change the shape of that object without metal cutting and without melting it. Okay, so when I say cold working involves shaping using equipments without fracturing it, without using any cutting tools to cut it, or without melting it and pouring it into a mold. So do you think it's possible to transform an ingot? Do you remember what's an ingot? A metal chunk. Metal comes in the form of an ingot, right? So do you think it's possible to transform an ingot to a finished product using cold working process at room temperature? Do you think it's possible? Let's look at the slides and then you'll know whether it's possible or not. Yeah. So advantages. Let's look at the advantages of cold working. Cold working is performed in room temperature, therefore produces smooth and bright surfaces, no oxidation because no heat involved. Strength and hardness are increased. Why? Because now you're forcing it to bend, or you're forcing it to stretch, you're forcing it to transform to another shape. So at the point of transformation, you will find that there are built-up stresses, and these built-up stresses whereby the grains are fighting to and opposing each other, there will be an increase or surge in the strength of the material. Okay, can be used for hardening metals that do not respond to heat treatment, and close tolerance can be obtained. Can you tell me what I mean by close tolerance? Okay, so basically, and I told you, anything that you heat, if you remember in die casting, and I also repeated it in hot working. So when you heat it up above recrystallization temperature, and when it's cooling down, when a material is cooling down, be it die casting, even die casting, when you point the liquid metal into the casting, and when it has solidified and it's cooling down to room temperature, that's when material properties set in place. That's when you see a material expanding or a material shrinking, right? So in this case, cold working, in hot working, when material is cooling back to room temperature, there'll be slight changes in dimension. Okay, very minor changes in dimension, which actually make you have to be aware of this percentage of shrinkage or percentage of expansion, and you need to adjust your mold accordingly to compensate that shrinkage for the particular material. Okay, but you don't have to worry about that in cold working, because cold working is performed in room temperature, so you do not need to worry about material shrinking or expanding. Yeah, your material dimension is going to be exact, so you have a close tolerance in dimension that can be obtained. However, just like any other processes, cold working comes with disadvantages. What are the disadvantages of cold working? So cold working, more energy is required. You need a lot of energy to shape the material because you're doing it in room temperature. Okay, whereas in hot working, if you remember, the material was in its semi-solid state. Yeah, so it was like a plasticine. It was so easily molded, except that you know that your equipments had to be heat resistant in order for you to do the shaping process. But in cold working, you're doing it in room temperature. You are shaping the object without machining it, without melting it in room temperature. So you definitely need a lot of energy as compared to hot working or any other processes. Number two, you need to definitely have heavy equipment. That means high pressure, high force equipment in this shaping process. And despite all that, you may even face an issue where the material may fracture because of overworking it. So at the end of the day, what are the effects produced by cold working? You're shaping it in room temperature. So at the point of bend, if you're bending it, at the point of stretching, there will be built up stresses because you're forcing the grains to extend or shrink. Yeah. So stresses will remain in the metal unless they are removed by heat treatment. You will find that at the edges or points of bend, there will be grains or which are distorted or fragmented. So the grains are either distorted, okay, or fragmented. There will not be any recovery of the grains or metal properties because cold working is performed below recrystallization temperature. So if you remember, in hot working, the grain gains heat, it will vibrate, collide with each other and break up to smaller particles or subparticles, and these grains will rearrange itself in a more orderly manner. So there's a change in the mechanical properties of the material. But in cold working, the the grain structure remains the same. Therefore, there would not be any recovery of grains or metal properties. So the mechanical properties will be consistent throughout the process. Number 4, it is a very productive process. Okay, very productive process. Number 5, close tolerances of the product. And because there is no worries about material cooling back to room temperature, expansion of metal, cooling, expansion of metal, shrinkage of metal, no such issues here. So you can definitely maintain close tolerances of the product and you end up getting good surface finish. So how is it possible? Yeah. So if you really look at it closely, you are definitely not going to shape a material from ingot to a final product using cold working process. It's impossible. So what exactly happens in cold working is that you are going to use a pre-worked metal, meaning that you're going to take a metal from a hot working process. So you know that the metal already possesses good mechanical properties, good physical properties. Then you further work it in room temperature, meaning that if you remember, I spoke about hot rolling process. Please go and look back at your notes for hot rolling. Hot rolling is when you have metal, it undergoes intermediate transformation where you have bloom billet slabs. So you take a bloom or a billet or a slab, heat it up above recrystallization temperature, and you can transform it into the final finished product, which is probably a bar or a rod or a plate. So in this case, you are going to take a hot work product. Say you take a bar that is hot work, you bring it to cold working, and in room temperature, you are going to bend it. Is it possible to do a bending? Yes, obviously. So you're going to take a hot worked bar and you're going to bend it in room temperature using a bending machine. That is a typical cold working process. So if you have done this kind of bending, drawing in room temperature, but we did not realize that these are in technical terms called a cold working process. So I hope you have obtained some idea about cold working. Till we meet again in the next slide. Happy learning. Thank you.